Hi everyone, and welcome to the second part of Chapter 6. In this part, we will learn to measure noise in dB with the PDM sound sensor. A PDM microphone, or pulse density modulation microphone, is a type of microphone that converts sound waves into a digital signal. Unlike traditional analog microphones, PDM microphones are more resistant to noise, making them ideal for applications such as smart home voice commands, noise level monitoring, or even sound analysis. In this activity, the sound sensor will measure sound level in voltage and convert it to sound level in decibels. If the magnitude is greater than 0, the code prints the sound level in decibels at the shell console with an interval of 0.1 second. To start, we need first to enable the plotter function in Sony IDE to have a better visual on the sound level. Now we are ready to write the code for this activity. Line 1. Math provides mathematical functions. Audio bus I/O provides audio input and output functionality. Line 3 configures the microphone to use GPIO pins GP3 and GP2 for audio input and sets the sample rate to 16,000 samples per second with bit depth set to 16 bits. Line 4, an array named samples is created to collect and store 6,000 audio samples per cycle. Line 6 to 7 defines a function log10 of x to calculate the base 10 logarithm of value x. This is used to convert the sound magnitude to decibels. Line 9 to 12. This function calculates the normalized root mean square of the audio samples. The variable values is an array of audio samples measured from the PDM microphone. It calculates the RMS by subtracting the mean value from each sample, squaring the result, and then taking the square root of the average of the squared values. Line 15. Record audio samples from the microphone into the samples array using mic record. Line 16. Calculate the magnitude of the audio signal using the normalized RMS function. Line 17 to 19. If the magnitude is greater than 0, indicating that there is some sound, calculate the sound level in decibels using the log10 function and print it to the shell console. Line 20 to 21. Else if the magnitude is less than or equal to 0, a message is printed indicating the magnitude is too small to be calculated. Let's run the code and try this program together. Sound is generated through the vibration of objects, such as when a drum is struck. These vibrations set the surrounding air molecules into motion, resulting in the formation of sound waves. Sound sensors are now integrated into almost all of our daily devices. For example, smartphones utilize voice recognition technology, enabling users to interact with their virtual assistants simply by speaking commands or queries. Well done completing part 2 of Chapter 6. In the next video, we will create a noise pollution monitoring system. Thanks for watching, and I will see you in the next video.